All right. Hello, everyone. Welcome to the first episode of Crossing the Streams. Yes, we are crossing the streams despite what those in the Ghostbuster universe told us not to do. It did save the day in Ghostbusters. And today we're going to be crossing the streams, talking about event streaming and building event streaming apps and everything in the Apache Pulsar space. I am one of the co-hosts here, Matt Yonkovit. I am Director of Community at Stream Native, and we are joined by our other co-host, Timothy Spann. Tim, how are you?
I'm doing good. I ain't afraid of no stream.
Oh, look at that. He's even going pun. He's going pun related already, and we just started. So we are here to start this podcast off with a bang, but we are planning to go through and talk to other people who are building apps that require a modern infrastructure that relies on event streaming and an event-driven architecture. We're here to talk about people who are, using Pulsar, Flink, even Kafka, other things that are in this space. We want to hear how they're deploying these streaming systems and how it is making their lives easier and help you figure out what you can do with some of the technologies that are out there. So, Tim, why don't we start and you just give us a nice introduction for yourself to let those who are listening to our first episode here know a little bit about yourself.
Sure, that makes sense. I've been around Pulsar community for a little over a year. Before that, I was a engineer in the field for Cloudera, covering Apache NiFi, Apache Flink, Apache Spark, Apache Kafka. So I was in the streaming space for like 6 years through them, covering the intersection where we hit data lakes, databases, data warehouse, Hadoop, all these different incrementations of big data and all kinds of weird streaming data, in memory, IoT. I've got a big thing for devices, and that fits in well with getting data in a stream quickly, doing things with it. Before that, I was at Pivotal, where I was doing pretty much the same thing, but also a little bit on Spring and microservices, which has come back full circle now that Spring and Pulsar are actively working together on a couple of projects, which is pretty exciting for us who've done Spring and Java for a number of years. And I'm going to be out at the Spring conference later this year talking about it. We'll see if we go in full Ghostbusters outfit or not.
Oh boy!
Cluster on my back, carried around. Probably.
Well, that would be cool. We could do a cluster of Raspberry Pis on your back.
Because I've got some devices attached to my jumpsuit already, so we'll see.
What? Okay, wait. What is that device, and why is it attached to your jumpsuit?
Well, because I got a place to put it on a belt. This is one of the nice devices that come from Adafruit in New York. Lady Ada and the team there have some awesome devices. Obviously, now it's a little harder to get stuff because of global supply chain not using Pulsar. What are you going to do? This one is interesting because off the shelf uses MicroPython to send messages out every couple of seconds. It's got a couple of sensors here for temperature, humidity, pressure.
Wait, you have a pressure, humidity, temperature sensor on your suit.
Yeah, I got to figure out where to put it, and do I hook it up to the back? Maybe that goes in the back on top of the pack. I got to still build out a pack, but we'll figure it out.
But I'm still trying to figure out.
Going to Pulsar.
Okay, that's cool. But I'm still trying to figure out if you're just trying to make sure you don't go overheated. Was it something like your family's worried that as you go out in that suit, you could get overheated?
This actually is a use case that came up. I don't remember what year that was. A couple of years ago, I was working with a customer that does utilities.
Okay.
And they were working on a combination smart suit, which it probably would have made more sense to be a smart jumpsuit. So they had some sensors in there. So yeah, part of it is temperature. And then some of the other sensors I've got next to me make more sense. Air quality, carbon monoxide levels, other methane, other noxious gases. I mean, heat's important. You don't want to be overheating, but you definitely don't want to be breathing in some weird chemicals. That might be more important. Sends it right to Pulsar, goes to Central Command. Obviously you could change a color locally, but you could be busy, not really thinking
Okay.
about what's going on yourself.
So
And
what?
someone else can tell you. You get a ping in your wireless Bluetooth headset that says, "Hey, Tim, get out of there. Sensors are going off the chart. Maybe there's ghosts. Who knows? Whatever it is, get out of that building." So there is a need to have real time stream even in the physical world.
Okay, so but what you're saying, and this is actually a pretty interesting use case and a pretty cool thing, and you're saying that there is some entity out there that was working on suits for people who are working maybe in mines, maybe in
Dangerous
like
places.
sewers or with petrochemical plants, whatever. And so they are building into their helmets, their suits, whatever, the sensors that will report back to a central location. So if they end up passing out, then someone knows to go run and get them.
Yeah, or just obviously with all these things, the thing that's most important with streaming analytics is being able to do predictions. So predict to say, hey, temperature's here, number of hours in the field is here, location is here, gas levels are here. You got 20 minutes left before you got to leave that facility. And we could tell them, give them a timer and update that real time. And it also could be, they were also combining it with other streams, which is, again, the best part of streams is crossing them. You got the local sensors, but then I also have feeds looking at, local social media to say, hey, is there some event going on? Check public weather feeds, traffic feeds, transport feeds to say, hey, there's some criminal activity nearby. The highways are jammed. It's starting to rain. All your sensors are up. We're cutting our losses. Get out of there now.
Wow.
Or yeah, and it's very easy to join them. What's nice is get all those feeds into Pulsar, and then we join them with Flink SQL. Or any of the Flink SQL GUI tools that our friends have out there.
Now, I mean, we jumped ahead a little bit because that was an interesting use case that I didn't even expect to go into. It was just that when I see flashing lights on Tim's suit.
Well, they're not that flashy.
Okay,
I should have them flash maybe every time it does a reading. I don't know.
Okay. Well, either way, when I see that, it's like, what the heck? What's Tim doing? But now I understand. It's to understand, if his air quality is okay, and to alert that there is proof of life because Tim never leaves his desk, so that way his family knows he's still alive and stuff. So
or if I start putting out too much hot air, we know.
Yes.
Go,
We know when Tim's
talking too much hot air.
Yeah, Tim's talking too much hot air. But that's a very interesting use case. But here's the thing. I think that people hear that and they go, that's very cool. But they don't actually understand some of the technologies underneath that. And so I figure today, as we start this journey, we're going to talk with a lot of other people. Our next episode is going to have Matteo on it, who is the CTO at Stream Native. And so we'll get into, why Pulsar was created, what use cases at the beginning. But I think we really need to start with the basics, right? And from a basics perspective, when we talk about event streaming or we talk about messaging, what is that? And some people get it. If you've been doing it, if you maybe have written, a ton of old school applications, you probably used MQ in the past. If you are, look, he just cringed. For those who are just listening,
done that.
yeah. You might know what MQ is, and messaging systems and queuing systems, or you might be designing some applications to take of, care of event streaming. But my question is, if you're not in that space, maybe we can help people define some of these key concepts. And I think that the first one to tackle is, we'll start with what is the difference between, message queues and event streaming?
I mean, there's some debate for that. I don't know if you want to start with your opinion or you want to read a one-liner someone's put out there. There's some debate when one starts and what ends. Like, I think the problem is with everything. Once a new term comes out, people try to adapt the term and their tech to whatever the new thing is. So some people will say, "Oh, messaging." Well, yeah, Kafka does messaging too, and you don't want to JMS. There's same ideas, but yeah,
But
there's some differences if you want to be very precise.
so Tim, I'm going to use my noob because I'm noob. I'm a noob here, right? I don't come from this space. There are key differences. One of them obviously is with a queue, you're looking at writing to the queue and then pulling off the queue and that message disappears. And from an event stream perspective, it is appended and it just continually grows that, and you just move the pointer along in that list. Is that correct?
That is correct for some use cases.
For some use cases.
Well, I think the problem is, in a pure messaging queue, that's what should happen. It should be like a real queue. Put some on, take it off, but it's gone because you took it off. But, that doesn't meet every use case. So people have, added additional functionality, which, is it still a messaging system? Is it a hybrid system? Like, a lot of these will retain the message for a certain period of time, or we'll have ones that are persistent. You can put it durable. Oh, it's a durable message. We keep it for some period of time, or you keep it forever, or you keep it if it's in some state, maybe you got to do an acknowledgement. That's when all these things become complex and it becomes harder because people keep wanting new stuff and want to do different types of apps. So they add additional knobs and dials. So it started off, you're with the Atari joystick, and now you're with a console with 1,000 buttons, and it looks like, you're in a spacecraft, and you're like, oh, make sure you do these 9 things over here and tweeze this and this. Okay, and then your message comes in, goes out.
Okay, but Tim,
But
when should you...
theoretically, yes.
Yeah, okay, but so when would you use a message queue or that kind of pub sub model versus a stream? Like, give me a couple examples when you would use one over the other.
Well, I mean, certainly there's a lot of traditional apps that are out there that already do it. So you use it for that reason, and some won't work differently. The other is sometimes you want to use messaging as a way to disconnect systems, which is a best practice in a lot of, when you have 2 unrelated systems. I want to send a message between them. I want to send data between them or an action. Having it done asynchronously and having it done in a way that I don't care if either system's running is a really good practice, because then someone, brings it down, starts it up. I didn't lose anything. I'm not like trying to make an HTTP call and it happens to be down or I can't get there. This also lets you have security. So it's a layer of isolation. This was huge in the 90s, was the first time when you have the SOAs and the, you have servers sitting in the middle that would act as a hub for your data. You get it there and, either you pull it or it gets pushed. That's a really nice use case. Just having that async, just having that disconnection, and just having someone else in charge of not losing that. So it's not, you don't have to sit in one VM. You don't have to sit on one machine. You don't have to sit. It's a way to communicate between apps, between servers, between systems in a very logical, asynchronous way. That's the basics.
And so this lets you fire and forget.
Fire and forget. I sent a message. I did my job.
And this is a critical thing for when you're doing high throughput data transfer between systems and you don't want to block or wait. Right? And so, you don't have to go check the state. Was it delivered? You can have, especially with modern queuing systems like Pulsar has capability. You can have, retries. You can have, exception handling. You can try, have guaranteed delivery. There are things that are part of the system where you don't have to worry about it. So your app can say, yes, I need to write this transaction to this other system. And this is often used, in any app. Think of this as, we'll use a very classic example from a banking perspective, right? So, you do some sort of local transaction and, you need to send data or an audit log or something to, ancillary systems. How do you ensure that, when you upload that, where does it go? I used to work for a trucking company like 25 years ago. God, it's been forever. And they had to have a check on, like who's renting trucks to cross check like a watch list, right? To make sure that there wasn't some, suspicious terrorist activity or something, or this person wasn't on there. And so they would send the data out, right? And it was, a constant like, okay, send it out, make sure it gets delivered. But it didn't necessarily have to be real time. And so, that's another potential use case there. Now, we talked a little bit about event streaming with your devices, but maybe you can tell people, now that we kind of talked a little bit about that pub sub model, the queuing model, why event streaming? Why streaming? Like what's the key thing that people get from streaming over that queuing model?
Well, I think there's one part of the evolution, and a lot of that was driven by the cloud scale and, realized initially in things like Kafka is I need to be able to send messages, and things like ordering started to matter, and things started to matter of, different guarantees on it. I had to get it exactly once. I had to get it at least once. And things were a continuous feed of data. Messaging was, like email. I send one, and maybe I send another one. It's usually not continuous. It certainly could be, especially with IoT and other ideas there. Then you're like, is that queuing or streaming? With the streaming, it's, I've got log. Every time a log comes in, send that log event into my stream, and someone's gonna grab it right away, maybe do analytics or SQL or store it somewhere. I want data as it happens, or for a Spark use case, really small micro batch of a second or a couple seconds of a couple events together. But generally, as it happens, send it to me, because there's a lot of them, and I just need to get them in order, or I need to get them in something resembling an order. Maybe there's a keys, I don't care, but get it, do something with it as it happens, or very close to it.
So it's a big key difference between the queuing systems or the messaging and event streaming is how the volume of data and how real time or as close to real time as it gets, because it's kind of like getting your packages delivered, right? You can get your packages delivered and it can be like when it gets there. And that could mean that if you order two things at the same time, one arrives later than another. But if it is guaranteed delivery in a certain amount of time, like 2 hours, they're going to have your groceries within 2 hours before your ice cream melts. That's more on that streaming side.
Yeah, and I think another thing, you hate to put concept together with implementation, but a key factor that's highly differentiated when streaming came out was distributed nature. Much like Hadoop federated, file systems and storage, the same idea happened with streaming. When I think of streaming, no one's thinking single node, one server sitting somewhere, and everything runs through there, maybe a backup. People are thinking, I have a lot of small servers. It scales up and down as needed. These use cases are too big for one server. This really applies to the same period of, it's going to be hosted in the cloud, or now Kubernetes, it's going to scale out. I'm going to have clusters. I'm going to have concerns about failover because it's running continuously. I can't go, oh, we're taking the server down for the day or for the weekend. It's this is running 24/7. It's never slowing down. Maybe it'll speed up, but it has to keep running. So I got to be able to take servers in and out real time, scale up as more events come in. That tends to be the philosophical and implementation difference with streaming.
Yeah, I mean, it's the difference between maybe, taking sips through a straw versus drinking from the fire hose, right? So you need to be able to like scale to the fire hose size, drinking vessel, which is quite a bit. And I think that that's, a very important differentiation as well. Now, we did mention a couple of examples, right? So if we're tracking real time, what sort of things are happening in your sensors, or maybe we're tracking GPS coordinates from, people driving around. Classic application that is used in a lot of examples is kind of that Uber Eats or Grubhub type example where you've got food delivery. Where is your food delivery driver? Did the food delivery get to the restaurant, and is it in process, and what is the status of that? There's a lot of data flowing back and forth between disparate systems because it's not like there is one central device that sits there. It's 1,000 different people's phones that are tracking, where your food is, right? If I'm a delivery driver and I'm driving towards the restaurant, then my GPS coordinates have to go back up through the app. And then that has to go back out to my phone as a purchaser, and tell me where they are. And so we have to have this kind of two-way flow of data. But I think that one of the other things that's an interesting component is the new application architectures that we're building. While we have focused on kind of reducing the footprint and creating a lot of microservices, it's made it so there are not just like a couple of components that have to share data. Now there's dozens or hundreds of components that all have to pull data from one another and send data back and forth. And that's made the highways between the microservices and the systems even more critical. And, that capability to kind of move things back and forth efficiently, a really big problem that needs to be solved. What do you think?
Yeah, that's exactly on point there.
Yeah. And I think that that's the other interesting thing. When we talk about the streaming side or the pub sub side, people think that, oftentimes they need, just streaming because streaming is the evolution of, queuing. Is streaming really the same thing as queuing? You alluded to it not being before, so I'm interested in your take on that.
Well, I mean, it comes down to what your use case is. I think some people is every communication between something and something else messaging. I mean, you're sending a message, whether you call that message an event, an object, a record, a file, bytes, a blob. That's going and being messaged somewhere. Maybe it's going to multiple people. That is something that's not common in streaming is, a broadcast message. And that's something that you do with messaging and with Pulsar. I want to send a blast message out. I mean, there's sort of ways to implement that in Kafka, but it's heavyweight because it's not supposed to be doing that. Stream is usually coming in, going to a processor, maybe a couple. The more consumers of a stream, that can be, heavyweight slowing down your process. Especially if things are in order and it's exactly once, kind of implies only, one or, a failover one on the other side. A lot of times I want to send, I'd say I want to send an email. I'm blasting it out to 1,000 subscribers. If it only went to one and they get it in order and then they put it in a database and then someone has to go read it and then they get it. A lot of times I want to do a broadcast message or, a fan out, or I want it to go into The queue just acts as a way to process work. You know, something comes in, I want someone to work on it. I don't care whoever's available next. Scale this out as big as possible. That is a use case that's not going away. I want a lot of people to process this, so it makes sense for it to have something like we have in Pulsar for shared messaging. Comes in, whoever gets it first gets it. And you don't have to worry about duplicates or, some way you've got to manage that yourself. Messaging queues have that. If you look at, the enterprise integration patterns, I don't think all those are going away, and those are huge. There's a whole language for doing all these complex patterns of how, you connect systems together with these pipelines. You need some flexibility in how you subscribe to data and how you process it along, how long you keep it. There's a lot of decisions have to be made. So it's like, is messaging this fixed thing that always looks the same, and event streaming is the new shiny and you always do it that way? Sometimes you got to do both in the same pipeline. Sometimes parts of the data go one way or another. Maybe you got to split it out. Maybe there's one group is processing it work queue style and one group is getting it in order, because I'm taking CDC from a table and I'm going to put it in another database table, and that better be in order for that table.
Yeah, so there's a lot of considerations for sure.
It's not on or off stream or message.
Yeah. So Tim, you actually talk to a lot of people. Like you give a lot of conference talks on Pulsar type topics, on kind of modern architecture design. I'm curious, what are the most frequent questions that people ask you in this space?
Well, the questions that come up are, can I just do this with Kafka? Because Kafka's been around longer. People know it. They may already have it in their system, and they're like, why is there another one? It's sort of like, why do I use Kubernetes when there was already VMs? There's that one comes up a lot because people have Kafka, and they're like, why? What's different? Or people confuse Pulsar with Spark, or Pulsar with Flink, or Pulsar with Kafka Streams. I think there's so much nuance out there. It's very easy to not know when someone says, oh, stream processing or streams, and people are like, okay, data. Most people get the idea of data's coming in. Maybe it's an event. It's a big stream. It's continuously coming in. But after that, who does what part of the infrastructure does what, gets confusing.
Indeed. So I think in the next episode, what we're going to have to do is we're going to have to define where does Pulsar fit versus Fink versus Spark. I think we have to go there because you brought it up.
Yeah, you do. And we have to define what use cases go where, what part covers what thing. Like, that was a common one. People tell me, like, does this use case, should I do this in Apache NiFi, in Spark, in Flink, in Pulsar, in a message, or just in a database? Some things are in a stream. Some things are a batch.
That's true.
Some things never change, never move.
I don't know. I used MySQL back in the day for a queuing system for several apps that I regret.
If something's small, sometimes it doesn't matter.
All right. Fair enough. Well, so again, next time we're going to have Matteo on, and I think that we are going to have to, get that discussion going around when do you use Fink, when do you use, Pulsar, when do you use NiFi, when do you use Spark? I think that these types of discussions are things that could help people kind of understand this ecosystem a little more. And we'll also dig into a few other topics around, kind of the evolution of this type of system and why it's needed and why it was built in the first place.
Good topics.
Yeah. All right, Tim. Well, everyone, we hope you enjoyed episode 1 of Crossing the Streams. We will be back in another week or two with our second episode, and let us know if there are topics or themes that you want us to cover. Thank you very much. All right.